This is Unit 2, Lesson 3, Part 3. We are sketching graphs of the derivative curves from the function graph. In the last video, at the end of the last video, we looked at the beginning of an example where we had both the function curve and the derivative curve drawn, and we found different important features of both and how they related to each other. So we're going to start this video, by looking at the graphs and deciding some important features on our own and how we get to the point where we can sketch the curve. So one of the first questions we want to ask ourselves is, when the graph of function is rising, we'll say that the function increases, and when the graph is falling, we'll say the graph decreases. So we read a graph from left to right, just like a book. So starting at the left, on the graph of f of x, state the intervals of x which the graph rises. And what do you notice about the slope of the curve on these intervals? So if we look at our graph, going from left to right, we notice that it's increasing. It is increasing from way down here at negative infinity all the way till it gets to the horizontal tangent line, and then again it's increasing again from the other horizontal tangent line, and it keeps going to infinity. So that's how we're going to write our answer. Our answer is going to look like this. It increases on negative infinity. It's not quite at -1, so I estimate it to be 0.9. Or you can use the union symbol, and the other one is around 4.2, 4.1 to infinity. And then it says, what do you notice about the slopes? So the slope of the tangent line, the slopes of the tangent lines are positive. They're all going up. We have a graph that's increasing. So the slope has to be positive. Starting at the left, state the intervals of x where the graph falls. What do you notice about the slope on these intervals? So same idea. Let's go back here. And what we see is that, that from our horizontal tangent line to this section, the graph is falling. And if we were to draw slopes along this part of the curve in the light blue, they would all have negative slopes. So for part B, we're going to say that it decreases from -0.9 to 4.2, in between those two horizontal tangent lines. So the slopes of these lines, the slopes of the tangent lines, are negative. Okay, next question. At what values of x on the graph of y equal f of x does the function appear to have a maximum or minimum value? And what is the slope of the curve at these points? What characteristics of f prime occurs at these points? So we would have already mentioned them for part A and B, and what we notice is these are the two parts where we have a horizontal tangent line. So right here, and there's specific points. Right here is our horizontal tangent line. Right there is our point. So, whoops, wrong graph. Sorry about that. And right here. Okay, there's our point. Right there of tangency. So at what x values? These are specific x values. So you would want to say at x equals -0.9, and at x equals 4.2. And at -0.9, we have a relative maximum And at 4.2, we have a relative minimum. And what can we say about the slope of the curve? The slope is 0 at those two curves. So the slopes of the tangent lines, that's above, tangent lines are 0. Okay? Now look carefully at this one. Why does the graph of f prime reach a maximum value near x equals 1.5? Can you explain what is occurring at x equals 1.5 on the graph of f of x to create this minimum on the slope graph? And we had already discussed this in the last video, so it's good to review it. What we have happening here is that's the point that I highlighted here in red, is that point right there is our point of inflection. And if you notice, it's where the graph is changing direction. So the graph is decreasing along here, and the concavity is changing. And then when it gets to that point, the concavity flips over, so the slope graph will flip over as well. So that's what's happening. That's our inflection point. So at x equals 1.5, the graph of f is changing. I don't know why I did that. That's weird. From being concave down to concave up. So this example is to help you understand how to break down a graph and look at it. It's very common to find 2 or 3 graphs together on the same grid on the AP test, and you're supposed to decide which one is the derivative, which one's the original function, and we're going to start talking about second derivatives, like the derivative of the derivative. So you have to be able to pull out all those features from each graph and figure out how they're interconnected, like where it's increasing and decreasing, where you're going to have horizontal tangent lines, all those kinds of things. So here's what you want to have going through your head as you go through this. To sketch an f prime graph, a slope graph from a curve, you want to describe how the slope changes from left to right along the curve. Notice the intervals where the slope is positive, negative, or 0. Write down the changes as they occur on the number line. Notice where the x-intercepts occur, and pay attention to where the function is above the x-axis and where it's below the x-axis. So that's going to come out to play in the slope graph. Okay, so let's take this curve, which is similar to the last one, but not exactly the same, and let's try to draw the slope curve. Okay, so some features to notice is here the graph is decreasing. So we're going to have a negative slope in this section on our slope graph. Okay? So we're going to have negative numbers on our slope graph. What we're going to notice here is that we have a horizontal tangent line . And then we are increasing along here. Okay, and if you notice, our concavity has changed. So right in the middle of this curve, we have an inflection point where it flips over. And I also want to point out that we have positive slopes here. Again, we have another horizontal tangent line. And then we are going to have negative slopes on this side. because we're decreasing. Okay, now I didn't really do that as I went, but let's fill in our little number line here. Okay, so on the number line, and you want to line it up with the number line you have there above you. So at -2 here, we have, that's our first break. We have G decreases. So that's going to be the same for G prime along here. It's all going to be negative numbers because it's decreasing. So we're going to have negative G's primes. And then here at -2, we're going to have a 0 slope. And then we're going to be increasing till we get about 3.3. That looks about good. And we're increasing through here. If that's the case, then our slope curve has got to be positive numbers. And then we have another 0 here. So after that, the function decreases. So we're going to have negative slope again. So on our slope graph, what we're going to have is that inflection point, which I didn't mark on the graph here, happens at about 0.8, so right around here. That's my inflection point. So that's an important point on the graph. And what I'm going to notice is that turns out to be the maximum of my graph. So I had a horizontal tangent line at -2, which corresponds to a 0 on this graph here. And then I have a horizontal tangent line at 3.3, which means I have 0 slope. Remember, this is representing the slopes. And then I'm going to have a maximum at 0.8 right around here. Okay, so what you want to remember is my slopes were negative until I got to the horizontal tangent line. So it's going to come up like this. Those are my negative slopes. And then from my horizontal tangent line to here, and then back down to the next horizontal tangent line, which happened there, those are all positive values because the function itself is increasing through here. So that's this whole section translates to this. And right in the center of that is going to be that inflection point. And then after that, I have negative slopes again, so the graph's going to look like this. So going back to my number line, G prime is increasing through here. And G itself is concave up till we get to the point of inflection. And then after that, G is concave down. And it's decreasing. Now don't worry right now exactly how I got where that maximum value is. We're going to learn how to do that later on. It's just being able to identify the different parts of the slope curve. Okay, so filling this all in, so we marked the number line above where g of x changes from increasing to decreasing. At these x values, the slope of the curve is 0. That's where our horizontal tangent line is, where it changes from increasing to decreasing. On the function, we refer to these extrema or a max or a min. So they're maximum or minimum point. Notice how the graph of g of x changes from concave up to concave down. Estimate the x value where this occurs and place this on the number line to the right. You will see that this becomes either a maximum or minimum point on the graph of the derivative. This is known, as I've said, as an inflection point or a point of inflection. and then we created the graph. Okay, and then finally, finding derivatives from the table. We've seen that it's possible to estimate the numerical value of a derivative at a single point by finding the slope of the secant line passing through 2 points on the graph. Let's explore how this can be done using a table of values for a continuous function. So that's important, though. We want to remember that this is a continuous function, otherwise this process won't work. So use the table of values for y equals f of x, define the derivatives for each x value, describe the behavior of the function, and explain your reasoning. Okay, so in -2, so here is -2, I'm going to find the slope of the secant line through that point. So I'm going to use the points on either side of it. So f prime of -2 is going to be 4 minus a -6 over -1 minus a -4. So f prime of -2 equals -10 thirds. Oh, I'm sorry, positive 10 thirds. Positive 10 thirds. So the function behavior, now I have a positive slope, so that means that the behavior of the function has to be that it's increasing. And my justification is that, so at -2, 2, f prime of -2 is positive. Okay, I'll do one more and then I'll leave the other ones for you guys to do, and I'll just show the answers. So next I'm going to do f prime of -1. So I'm going to highlight where -1 is, and I'm going to use the points on either side. So I'm going to have -1, the y value, minus 2 over 0 minus a -2, so plus 2. So f prime of -1 is going to equal -3/2. And since the slope is negative, that means the function itself is decreasing. And my justification is that at -1, 4, f prime of -1 is less than 0. So take a moment and do the other parts, and then you can check them here. Okay, so here are the last 3 answers then for x equals 0, 2, and 3. And one thing I want to point out is at x equals 0, that's going to be constant because we are at a point where we have a relative minimum if you look at the table. So this is a relative minimum because we're moving from a decreasing area to an increasing area. So that's going to be where we have a minimum. All right, so let's summarize our important facts and findings for this section. So if f prime of x is less than 0, then the graph of the function is decreasing at x equals a. If f prime of 0 is greater than 0, then the graph of the function is increasing at x equals a. Number 3, a relative maximum occurs on a function if f prime of x equals 0 and the derivative changes from positive to negative. Because we were going up and we got to the top, we have a horizontal tangent line, and now we're going to start going down, so our slopes will be negative. And just the opposite occurs. A relative minimum occurs on a function if f prime of x is 0 again, and the derivative changes from negative to positive, because that means we had negative slope lines and we get to the bottom and then they change to positive slope lines. Okay, if any of this needs clarification, we will be going over this in class.